everyone, and welcome to the first video of the Chem Gems, and we will be following the IB curriculum for Chemistry SL. So today we will be doing the first lesson on the particulate nature of matter. So first, let's talk about elements. Well, all substances are made up of one or more elements, and an element cannot be broken down into simpler substances through chemical or physical processes. There are 108 known elements, as we can see here on the periodic table, and the smallest part of an element is known as the atom. So now we're going to go into characterizing substances a little bit. So first up, we have compounds. So compounds are sort of, easily mixed up with molecules. The main difference between compounds and molecules is that compounds, they are made up of one or more different types of atoms. This is the key difference between compounds and molecules. Molecules are made up of one or more atoms. So here it doesn't have it doesn't need to necessarily be one or more different, but for compounds it has to be. So that's really the key difference. A compound is made up of more than one element that is combined in a fixed ratio. So this part is also pretty important because later when we talk about empirical formulas and stuff like that, the ratio part will be necessary. Compounds have different chemical and physical properties from their component elements. So for example, water, commonly known as H2O, has different properties than, say, CO2, which is carbon dioxide. We can sort of see that from its chemical makeup. CO2. Then we can talk about mixtures. So mixtures can be elements or compounds. The components of a mixture are not chemically bonded. If components of a mixture are in the same phase, it is homogeneous. And if they're not in the same phase, it is heterogeneous. So here we have a nice mind map. If you guys would like to screenshot it and take a look. Now we're going to talk about properties of substances. So they're mainly divided into two. First are chemical properties, and the second are physical properties. So chemical properties can only be observed when a substance goes through a chemical change. So chemical properties are really about how the chemical composition of a substance changes. So for example, its flammability, its toxicity, and its reactivity. Then we have physical properties. So these can be observed when they go through physical change. An important thing to note is that for physical properties, the chemical composition of the substance does not change. But for chemical properties, the composition changes. So for physical properties, you guys probably seen this, but it's like, boiling point, melting point, hardness, electrical conductivity, things that sort of you can see. Next, we're going to talk about separation techniques. So, as we said before, mixtures are not chemically bonded. Therefore, they can be separated by all sorts of physical means that we will talk about later. So, properties that need to be considered when determining the best method of separation are solubility, melting point, boiling point, and whether the mixture is homogeneous or heterogeneous. So the techniques that we will be covering are solvation, filtration, evaporation, distillation, recrystallization, and chromatography. Well, here is sort of a common apparatus that we use for a lot of these separatory techniques. The first is so we're talking about separatory funnel. So it's used to separate two immiscible liquids. So what do we mean by immiscible? It means that they do not mix. So we can see here there are two clear layers, and from this we can tell that they are immiscible. That is what we mean by immiscible. And if you think about it the opposite way, miscible liquids are when two liquids are able to mix with each other to form a homogeneous substance. So how you usually use this? The mixture is shaken with a stopper on, then it's allowed to stand. 2 layers will form as we see, then the stopper is removed. The more dense layer will run off by opening the tap, so this is the more dense layer. First, let us talk about filtration. So filtration is used to separate an insoluble substance from a liquid or gas. So how this works is that a mixture is poured through a filter. Usually this will be filter paper. So you would set it up, say you have 2 pieces of filtering paper, they're usually circular. You would bunch them up into a cone. This paper cone that you've made will be put into a funnel. A liquid is going to be poured through, so into the filtration paper and through the funnel. The liquid will be going through into a beaker. So the insoluble solids will remain on the filter. So here, say you have some leftovers, that's called the residue. And the liquid that passes down through is called the filtrate. Then we can talk about solvation. So solvation is basically a general term that we use for separation techniques based on solubility into 2 immiscible liquids. So as we've talked about earlier, with the separatory funnel, this is where you could use the method of solvation for. So a liquid is put into a container with another immiscible liquid. The container is shaken, and the solute of one mixture is dissolved into another. So what this means is that, remember, immiscible means that there are 2 layers that do not mix. So for a separatory funnel, say you have this, and you have 2 different mixtures. Then it is shaken, and say that we have some solute in the blue mixture. After shaking it, and then what will happen is that because the black solute is more soluble in the blue mixture than it is in the red, the black solute will, after being shaken, get into the blue solvent. Then what happens? You can, again, use your separatory funnel and then allow the red to run off into a beaker. Then what happens is you can extract this pure black solute using evaporation. So that is solvation that's based on the solubility of the substances that you're handling with. Then, okay, we kind of already touched on evaporation. So basically, you're using it to separate a solution, and you only want the solvent. So the mixture is warmed up, the solvent of a solution is evaporated. After evaporation, only the solute remains. Then we can talk about distillation. So this is really sort of evaporation as well, but then you're using it to separate a solution, leaving one as water H2O. The mixture is put into the distillation apparatus. So this looks something like this. So this is the distillation apparatus. You have the solution that you want to distill over here. And then the vapor will rise up, and the thermometer here will be to measure the temperature. The water will run through this condenser, and it will fall into the flask. So really, you can also use this distillation apparatus for evaporation as well. And for evaporation, there's an interesting point where you can also use the principles of boiling point to separate 2 miscible liquids as well, because different substances have different boiling points, and you can use that. For example, let's say you have a liquid here of A and B, and say that liquid A has a pretty high boiling point, high BP, and let's say that liquid B has a pretty low boiling point. So if you have A plus B together, well, B would probably boil first because it has a lower boiling point, and so the vapors of liquid B would rise up, pass through, and be separated down there. So you can also use that for evaporation as well. Then we have recrystallization. So this is used to purify solids with impurities. So what would happen is a solid is dissolved in a solvent to prepare a saturated solution. So what do we mean by saturated? Let's say you have 2 beakers that are filled with NaCl aqueous. So you have salt basically in water. But a thing to note is that they have different amounts of water, but say maybe the same amount of NaCl. So I don't know, 1, 2, 3, 4, 5. Let's just say hypothetically we have 5 NaCls, even though that's not really scientifically correct, but yeah. So what would happen is that we have beaker A and beaker B. Beaker B would be the more saturated beaker with salt, because for the same amount of NaCl, you have less water, so less solvent in this one, but for here, you have more solvent. So that's what saturated means. So you have the solute sort of being more than the solvent, I guess. So yeah. A solid is dissolved in a solvent to prepare a saturated solution, so B is the saturated solution. Once the solvent cools and evaporates, it leaves behind a pure solute. So maybe, I don't know, you guys in primary, maybe if you guys done like this experiment where you have like a, you put like a toothpick, a skewer or whatever, and then you have like a string that's here, and then you leave it there for a few days, and then you will find out that you have like crystals. That is sort of what recrystallization is. It leaves behind a pure solute by boiling it in a solvent and leaving it there. So we're going to talk about chromatography. Chromatography is used to separate mixtures containing minimal amounts of an individual component and can be used to test purity. So chromatography can also be used to separate and identify complex mixtures quantitatively and qualitatively. So it consists of a stationary phase and a mobile phase. So let's see an example of this to better understand it. So here we have a beaker of water, and then we have a blotting paper, but we also call it a chromatography paper, and we have, say, sort of a splotch of black ink over here. And because black ink actually consists of multiple different colors, and so what will happen is that when the water rises along this chromatography paper, because it's soaking up the water, the different dyes that consist the black ink will be separated. So let's say, I don't know, you have, when the water reaches here, you'll get your red ink. When it reaches here, you'll get your brown ink. When you reach here, you get your green ink. So yeah, something like that. And so the stationary phase will be the blotting paper, and the mobile phase will be the dyes. So different colors in the ink move at different rates and separate into different colors that we see here. You can also use it for sort of things with a lot of dyes in it as well. And based on how far the component travels up, it can be identified how the component is to the mobile phase. So what this means is the further, whichever dyes travels the furthest, its particles are most likely to be the smallest because of how attracted it is to its solvent.